Hello everybody to my talk about how to serialize the requirements. So we heard 3 talks right now about how to get to the requirements, how to decipher them from regulations. I went on the topic from a bit different perspective, that is how to exchange the information about those requirements in a machine-readable way. And currently there are 3 different standards, 3 different technologies being employed by buildingSMART International that I have compared in our study. So, what are we going to talk about? What I'm going to tell you in the next 10 minutes is really about this checking language, about the exchange requirements and the language of how to serialize that. I have a short introduction for you, then we have some serialization possibilities that we need to explore, some examples from the domain, the comparison, and of course, the most important findings. So, if we look at the motivation, you all can recognize immediately that there's something wrong here. Although I didn't really specify what the requirement is, all the puzzle pieces fit together. So let's say that requirement is good. If you were to look on this puzzle from the backside, you would think everything fits. But if you look on it from a correct perspective, you realize some pieces are telling a different story than some other pieces. And the motivation is, of course, how to recognize that, how to serialize this type of thing that you've been basically learning your whole life, which is, image recognition and pattern recognition, how to teach that, how to tell that to the computer. And stemming from this, of course, if you look at the big picture, how the industry works, we have a sort of a list of requirements. We have 3 talks already on this. I believe the next 2 are all on that part. Some other talks were also explaining about the deliverables. We all know that there's some magic happening in between in the industry where nobody really knows what's happening, but somehow we get from the requirements to the deliverables, and we want to check those deliverables against the requirements. And if we want to do that, we need to know what the requirements are. We need to be able to exchange them. And of course, we want to do everything with OpenBIM. We want to do everything with open formats. And the focus, of course, is how to do the requirements. So I'm not focusing, for example, on IFC. I believe there were talks on this. That's more on the deliverable sides, or BCFs, for example, for delivering the checks, the results of the checking. Let's see how to do the requirements. Right, what are the 3 different serialization possibilities that I looked at? Well, those are the IDS, mvdXML, and Gherkin with the Python implementation. If we look at the most recent, I believe, standardized is the IDS, the Information Delivery Specification. It has 6 facets. You can check for properties in IFC files, you can check for materials, you can check for relationships, for classification. There are 2 more, I can't remember right now. But you have a very fixed set of what you can check. You have a very fixed set of what you can express in the IDS language, and it's a declarative language. You basically produce IDS XML files. A bit bigger vocabulary has the mvdXML. Again, it's a declarative language. You exchange mvdXML files, but you have an unlimited resource of how many different facets you want to be checking. So IDS has decided to hard-code 6 facets. In mvdXML, you define the facets yourself within the mvdXML file. So you really also you're capable of having different directives of what you want to be checking within the IFC file. And then even bigger than that is, of course, the Gherkin and Python implementation, because you're dealing with a programming language. Basically, Turing-complete programming languages, you can do whatever you want, as long as you know how to program, as long as you know how to do it. So there's an openness to possibilities, but there's also a specific cost to it, because you need to do it. So currently, for example, buildingSMART has approximately 70 functions implemented in their implementation. Right. Those are the 3 that I looked at. Serialization examples, please look into in the paper itself. I'm not going to be showing you XML files right now, but if we look at what can be checked with these 3 serializations, what can be serialized. So I took some examples first and foremost from the IDS documentation. So the IDS documentation online already lists what it can and what it cannot do. It's a very transparent manner. And let's say, for example, an external load-bearing wall needs to have a fire rating property. Yes, that can be done with an IDS, with a property facet, but it can also be done with mvdXML, and theoretically possible also with Gherkin if you implement it. So the circles mean that it is technically possible. But on the other hand side, for example, that you cannot specify in either IDS or mvdXML, the fourth one there on the left, there must be no clashes between structural beams and pipes. None of them do geometrical requirements. You cannot express that. But then on the one from the second to last, the name of all door types must be unique. This is something that you cannot express with IDS because there's no this uniqueness type of requirement that you can express that, but mvdXML allows for that with its grammar. A few more examples. For example, all models shall load in under 3 minutes by major software vendors. You cannot really specify this requirement in any of the three serializations. This is really a functional requirement, not that much a data model requirement. Right, those are simple examples. We also had some examples from the Applying IFC for Railways project. It ran for the past 4 years. And one of them was, for example, hey, I have a signal, I have a railway signal that should be linearly placed on an alignment. The alignment is called 001R, and it should be at station 69.395 meters. That was a requirement. I believe it was the Swiss Railway that had this and said, I want to be able to convey this in an open data format. How this looks in an IFC file, this is the snippet of expected IFC structure. So you've got this IFC alignment on the left bottom. This one has, through rel positions, an IFC referent attached. The IFC referent is basically stating at this station there is something, and on this IFC referent you have, through IFC rel positions, an IFC signal. Of course, the placements also need to be carefully designed, and you need to have the geometry of the alignment, the gradient curve, in order for everything to work. And if you look at how does IDS do it, how does mvdXML do it, so full transparency in Gherkin, of course, you can do this. You could implement it as a one sentence, you could implement it as a generic sentence, depends on how much programming effort you want to be doing. But the other two that are limited vocabulary declarations, the mvdXML can do it already with the predefined concept templates that are shipped with the IFC documentation, with the IFC specification. On the other hand side, IDS could only do approximately half of it. So there was no way to say, for example, I want to be linearly placed along an alignment. You could say, I want to have a referent that has a predefined type station. That's completely valid and possible. But hey, I want to be connected. I want to connect the signal to my referent. That's a no-go. One example. The other example from that was the Austrian railways, I believe, where they were modeling also the context of their railway station. So you can see the railway station with the buildings there in yellow, with yellow roofs and white walls. Those are the station buildings that they were interested in, that they are also owner of. And the surrounding buildings in red brick-like color are just basically, whatever stands around the station. And they said, we want to be able to exchange, we want to be able to check the IFC file that it has these buildings and that they are modeled correctly. We're not interested in the we're not interested in stories for the red buildings. I mean, they are marked red, but they are basically not their own buildings. We are, however, very interested in how our buildings look like. So you have a specific applicability that you need to filter the data, and on this applicability you have specific requirements that are for these buildings. Again, if you have a look, IDS cuts at about a half of what I've just said. We want to check mvdXML again with already prepared concept templates from the specification, can do all of it. So, from the examples, let's see the comparison. The WD entity, of course, that was the scope, is the buildingSMART International. That was how we also limited. There are other specifications on how to do, for example, RAISE, but that's not from buildingSMART International, I believe. That's Nick Nisbet's very well provided work. They're all developed on GitHub. Everything's open source, so you can, of course, propose extensions, propose ideas, contribute to the whole thing. The checking scope, of course, is the one that really strikes us as one of the major differences between the three. That, of course, in IDS you have this limited scope with the 6 facets. With mvdXML you have full scope of alphanumeric data, but of course no geometries there. And on Gherkin Python, you can do whatever you want to program. However, it comes with the with a bit of a bad taste to it, because it's not a controlled vocabulary. You have to program Python in this case. Checking criteria, you can check for existence, you can check for values. In mvdXML, you can check for uniqueness, for cardinalities, and in Python, of course, you can check for everything. Also combinatorics, as we've seen in the previous presentation about this all logical interconnections. In IDS, currently only AND is possible. In mvdXML, you have the whole plethora of it. Elisabeth is looking critical.
The applicabilities in IDS are joined
with AND. With not AND. All right, okay. I'll have to correct that part. Yeah, of course, because it's, yeah, I stand corrected. But also if you look at how available it is to the community, of course. It's one thing to have the standards, but it's also how available is it for everybody to use. There are a lot of IDS implementations out there. For mvdXML, it's a limited, there's a limited implementation. And of course, the Gherkin and Python implementation is buildingSMART International only. So, our findings, if we go and say, well, the way we see it is if you have a limited line, use IDS. It's a very strict, a very small scope, and you can really do already a lot of things with it. If you want full control over the IFC graph structure, over the IFC exchanges and everything, use mvdXML. And if you need anything geometrical, you need to program Python, so choose Gherkin with Python. And recommended scope, we would say, so if you look at how IFC schema is defined, IFC schema currently in Express, that's a given, that's the foundation. And with it, you have the general usage, the IFC specification, that's the whole thing that also includes, for example, already concept templates. And the international model definitions, that's currently what's being implemented extensively on the buildingSMART side with these Gherkin rules. So what are the rules that everybody should abide by? What are the general best practices for IFC data exchange? But if you have any specific rules for your national rules, for your projects, for your individual companies, of course, use the IDS for these limited lines. So you can really build up and you can see this strict division between what's the internationally common, but what is then the project specific. And here is where mvdXML, I believe, strives me as a really good standard because it supports that's all. So it's really a complex thing, of course, because it supports everything. And I find it as a best way forward. And with that, I thank all the IFC4A project stakeholders for funding this and you for your attention. I'm open for questions.